Now that we've learned more about IPFS and the token URI, we can actually go to a marketplace like OpenSea and actually see this for ourselves. OpenSea is a marketplace for selling NFTs. And if we scroll down, we could go to really any NFT. Like for example, the Pudgy Penguins here, we could scroll down, really pick any NFT and look at it here. And if we go to its on-chain details, let me click this, we can see the source code of this. And if we scroll to read contracts, let's connect to Web3. Yeah, sure. Yep. We scroll all the way down and we click token URI of, which ID was this? 4785. Grab that, paste it in here. We'll get this back. And if we copy that, paste it up here, we can see this metadata object similar to what we were looking at before. It's got some attributes, it's got description, and then importantly, it has this name piece here. And if I copy this and paste it, we can see what the image of the NFT actually looks like. Now, important note, they're using HTTPS IPFS.io, which is okay because they're still using this IPFS. They're still using IPFS, but if the IPFS.io website goes down, this would render nothing. So ideally, when you're using IPFS, you use this syntax where you do IPFS : and then the hash, because this, starting your URI with this will point to the IPFS network as opposed to using this will point to the IPFS website. So this is a centralized website. If you start with HTTPS, IPFS.io, this is pointing to the IPFS network, which is a distributed decentralized network. So they're definitely different here. The reason a lot of people do this though, is because not a lot of browsers actually support IPFS. So this is HTTP and anyone can view it in their browser, but we could also use the IPFS.io of this. So I can even just grab this hash here. I could do IPFS : paste the hash in here. And since I'm using Brave, I can actually see this Penguin folder in here, and I can see all the different pieces that go in this folder. And then I would do Penguin 4785. Let's put 4785. Boom, and I can see this right off of IPFS. Now, this only works for me because I'm using Brave with a built-in local IPFS node. If you're using Chrome or Firefox or something like that, you can grab IPFS Companion, add to Brave, or you can just go to the IPFS site, IPFS here, install IPFS desktop, and then I could pull up my IPFS UI. And what I could do is I could once again grab this IPFS hash, copy it, paste it into my IPFS UI. And once again, I'd see the Penguin folder. See there's 3 GB in there. We could scroll through the folder and look through the files again. So you don't have to download the IPFS extension if you don't want to. However, it is a nice thing to have in your browser because a lot of projects do use IPFS, and it's much easier to render them if you're using that IPFS companion, if you're using Chrome or something, or just use Brave browser because Brave browser comes with a built-in IPFS node. And the other thing is, once you get your own image, what you could do is either in your own IPFS node in your browser, or you could then upload this image to your IPFS node and get the hash and use that as the image URI for your own NFT. But if you want to make this a little easier on yourself, for now, we can just go to Foundry NFT F23. Let's go to script. I know we haven't written this yet, but we go to interactions.s.sol. We copy this IPFS hash. We copy this IPFS URI, paste it into the browser. And if you do have the IPFS node working, then you'll be able to actually see it like so. This is going to be the metadata for the pug that we're going to use. When you're uploading to IPFS, you'd have to upload both this image and this file, which on the image section has the URI of the image. So you'd upload the image first, get the image URI of the image, and then upload a file that looks like this with the image URI like in here so that we can see this little puppy. But for us, if you want to do all that, feel free to try it out. Feel free to give it a whirl. But for now, we're just going to use this. Anyways, okay. Back to our NFT. We could just literally paste the token URI in here so that every one of our dogs would be exactly the same, but let's make ours a little bit more creative. Let's allow people to actually choose their own token URI, choose their own, what each one of their tokens will look like. So we'll allow them to pass in a string memory token URI. And then what we'll do is we'll say, we'll have a mapping at the top here, a mapping of UN256 mapped to string called do private s underscore token ID to URI, where this mapping will get a token ID and we'll get out a token URI. So we'll say s underscore token ID to URI, s underscore token counter equals token URI. And then we're gonna have to do s underscore token counter plus plus, like that. We're gonna have to add 1 to it. And then we're gonna want to mint an NFT. We're gonna wanna set the balance of this and everything. In the OpenZeppelin ERC721, there's a safe mint function that we can actually call. So we're going to call this safe mint function underscore safe mint message.sender underscore s underscore token counter. So this safe mint function makes their balance +1. It sets up their token counter and a few other things. So we'll have the safe mint. And then down here, instead of just returning some string, we'll say return s underscore token ID to URI token ID, like this. Okay, cool. So now we have this real basic NFT, although it's even a little bit more advanced, right? Because anybody can mint an NFT and make it look like whatever they want, right? And if you do mint this NFT, this is a great opportunity for you to play around with minting NFTs that look different.